All right, today we're going to talk about domain and range, how domain is x or your input and range is y or your output. Keep in mind, f of x is the same thing as y. So we've got the equation 5x squared minus 1. Domain is x and range is y. And we've been given a domain of -3, -2, 0, 2. So when we put this into our equation, we put in our -3 and we slide it into the equation, and what we get out is a 44. Notice the -3 is in parentheses because that's all that we're squaring. We're not squaring the 5. So if we input the -2, again, the -2 is in parentheses, and what we get out in this situation is a 19. So we plug in our 0, and we get a -1. We plug in our 2, and as we plug in our 2, you'll notice we get out a 19. So our range, being our output, or our y values, would be 44, 19, and -1. We don't put the repeat value. You don't put 19 in there twice. So even though we've got 4 input or domain values, we only get out 3 range values. Now another way we could look at this is on our calculator. So we could go to y equals. We could plug in our equation, 5x squared minus 1. So we've got our equation in there. We go to second function, table, and we look at our table. And the numbers we were looking at were -3, which gave us a 44, -2, which gave us a 19, 0, which gave us a -1, and 2, which gave us our other 19. So by looking at your calculator, you can see the domain and range of any equation.
All right, now I'm given a range of 1, 2, and 3. Range is the set of all possible y values, and I'm going to figure out which of these tables actually has a range of 1, 2, and 3. So I know a range is y, so I'm looking at the y values, and this table has y values of 4, 8, and 12. It is not a match. Looking at my second table, this one has y values of 1, 2, and 3. Means it's got a range of 1, 2, and 3. Found it. Now I'm going to see which of these graphs, which represent functions, have a range of 1, 2, and 3. Now these are discrete graphs. They're just disconnected dots. So I'm looking for the range, which are the y values. So I'm going to use my range finder, which works on the y-axis. So here we go. I'm going to move it up, and I'd like you to do, let's see, maybe not. As this rangefinder hits my graph, I want you to mark that on the y-axis. See right there? I'm going to actually use my highlighter to do that. Hit it at 4. Keep on going. You can see that it hits my graph when y is 8. And it hits my graph right here when y is 12. So I'm looking at my y-axis, and I see that I've 4, 8, and 12. And is that what I wanted? Nope, I wanted 1, 2, and 3. Not a match. Now I'm going to use my rangefinder to look at my second graph. Okay. Going to move it up the y-axis because I'm looking for my range. Here we go. And you can see that I would highlight at 1, at 2, and at 3. So I'll do that real quick. Okay. And you can see that that's actually a match. This graph does have a range of 1, 2, and 3. But I want to show you something cool. Here we go. I'm going to actually look at the ordered pairs for each of these points. So I've got 4, 1, and I have 8, 2. And my third point has an ordered pair of 12, 3. Hey, I'm looking for my range. So I'm looking for all the possible y values that are on my graph. Check it out. This is a possible y value. This is a possible y value. This is a possible y value, because each of these ordered pairs is just x comma y. You can see just by looking at the ordered pairs that my range is 1, 2, and 3. Can you figure out what the domain is just by looking at the points? Hopefully you said 4, 8, and 12. Okay, so now we're going to look at some scenarios. In this case, I am a roller coaster ride operator. And I'm trying to figure out whether my range is 1, 2, and 3. Range. Wait, range is y. That's also the output. I'm trying to figure out whether the output, my output, is going to be 1, 2, and 3. What does that mean? Well, each car can hold 4 kids. And what's going to happen is that a bunch of kids are going to come up and they're going to arrange themselves in groups of 4, and I'm going to put them on cars. So they're going to come to me and they're going to say, oh, we have 4 people in our group, or 8 people in our group, or 12 people in our group. That's the input that they're going to give to me. And I'm going to say, well, then you need the output, which is either 1, 2, or 3 cars. So you can see here that the range, the set of all possible output values, are 1, 2, and 3. This one looks good. Now I sell pizza, and my customers are going to come to me and they're going to tell me how many pizzas they want. And I'm going to tell them how many kids they can serve. I know that each pizza serves 4 kids. So they're going to come to me and they're going to give me an input value of how many pizzas they want. They might want 1, 2, or 3 pizzas. And I'm going to tell them, well, then you can serve either 4, 8, or 12 kids. So in this case, although it has a domain of 1, 2, and 3, the range is 4, 8, and 12. Not what I'm looking for, because I'm looking for a range of 1, 2, and 3. Now we're going to look at a continuous graph. And on this continuous graph, you'll notice that one of the endpoints is solid or closed. That means that point, which actually is -3, 2, means that point is on the line, or really on the line segment. So as we go down the line and we go to the other endpoint, we notice that that is an open circle. That means that line segment extends all the way to, what would that be, 4, -3, but it doesn't include that last point. Okay? It's not inclusive. So let's figure out what our domain and our range are. I know that domain is x. Now, since this is a continuous graph, I'm going to be using inequalities. So I'll be using a compound inequality since there is a minimum and maximum value. So let's use my domain finder because domain is x, and I'm looking for my domain. Here we go. I would start highlighting here. Do you see where it's hitting my graph right here? Well, I'll just highlight at the end. And you can see that I will stop highlighting right there. Wait a second, it's an open circle. So let me make sure that I'm good about this. This is a closed circle where I start. And this was an open circle where I ended. I highlighted right here. Now I just have to represent what I highlighted because those are all the possible x values. That's my domain. My minimum value is going to be -3. And I'm talking about domain is x, so is less than or equal to x. Now notice there's equality as a part of this symbol because I'm including a point that's a closed circle, which is less than, and I'm not using equality here because remember, this is an open circle, which is less than my upper boundary of x values, which is 4. Okay, now let's look at my range. Well, range is y. So I'm going to use my y-axis. Up I go. And you can see I'm going to start highlighting here. And I'm going to remind myself that it's an open circle by putting it there. I'm going to highlight all the way to this point here, which actually is a closed circle. So I'll just remind myself. Okay. What did I highlight on the y-axis? What's the lowest value that you see highlighted on the y-axis? Hopefully you see that it is negative 3. Negative 3, right there. And it's going to be just less than, because it's an open circle, it's not equal to, and range is y, which is less than or equal to my highest value, which is going to be 2.
What we have here is another continuous graph, but what you might notice about this graph is it has an open arrow on the end, and that arrow on the end means that that graph or that line continues on forever and ever. It goes to infinity. So starting out, right here we've got a closed circle, and our closed circle is at negative 1, 4. So we've got to see how we can write our domain and range with this going to infinity. Well, if you think about your domain, which is x, this domain continues on forever and ever. So x, since it's a closed circle, is going to be greater than or equal to negative 1. Our range also continues upwards towards infinity. So our range, which is y, is going to be greater than or equal to 4. Make sure you get all your activities done and turned in, and good luck on your EOC.